May 2024 will go down in history as the month the lights danced in strange places. People worldwide witnessed an ethereal glow in the night sky, the sun's explosive nature, eerie green, red, and violet hue, stretching from the Mexican deserts to the European skies. Every 11 years, it goes through a cycle of activity, fluctuating from solar minimum to solar maximum. During these cycles, imagine billions of tons of superheated gas hurtling toward Earth at speeds ranging from a few hundred to over 3,000 kilometers per second. These emissions typically reach Earth in 1 to 4 days. The sun ejects enormous amounts of plasma and magnetic field in explosive events known as solar flares and coronal mass ejections, or CMEs. It was the northern lights dancing at a latitude where they've never been seen before. Classified by their X-ray brightness, these flares range from Weka-class events to powerful X-class events. An X-class flare can be hundreds of times more powerful than a moderate M-class flare. While the radiation from a flare reaches Earth in about 8 minutes, it doesn't carry a large amount of plasma. Instead, it releases intense bursts of X-rays and ultraviolet radiation. The radiation from a flare can disrupt radio communications on Earth, but the real threat comes from their bigger, slower cousins, CMEs. This can cause them to slow down and eventually fall out of orbit. The radiation can also damage sensitive electronics, causing malfunctions or complete failure. Geomagnetic storms induce powerful electric currents in long conductors on Earth like power transmission lines. These geysers can overload and damage transformers, leading to widespread grid collapse and blackouts. The impact extends beyond darkness. These are essential for long-distance communication, aviation, and emergency services. Pilots depend on these communications for navigation and safety. Disruptions can lead to flight delays, detours, or even dangerous situations. This can cause acute health effects and increase the risk of long-term cancers. For ongoing missions like those on the International Space Station and future ventures to the Moon or Mars, space agencies must consider ways to mitigate these risks. It affects water purification, heating, and even financial markets and emergency services. It narrowly missed our planet, passing just 9 days before it would have struck. Experts estimate that had it hit, the economic damage could have reached trillions of dollars and taken years to recover. The 1989 geomagnetic storm in Canada left 6 million people without power for 9 hours. The spectacular auroras were seen as far south as the Caribbean. But more importantly, it caused widespread failures in telegraph systems across Europe and North America. Scientists and engineers worldwide are working on solutions to mitigate these risks. Imagine that level of disruption today, and you start to see the scale of the Carrington Event. A more severe event could cause much longer and more extensive outages. They provide crucial early warnings that give operators time to prepare. Power grid operators can take steps to protect their systems, and satellite companies can position their spacecraft to reduce risks. This includes installing equipment that blocks these currents, or developing protocols for temporarily shutting down vulnerable parts of the grid. This includes vital systems like GPS, cell phone networks, and weather forecasting satellites. Disruptions like these can impact navigation, communication, and even emergency response efforts. And in the Northern Hemisphere, it wasn't just the aurora that surprised observers. The same lights appeared in the south, too. They bring us both wonder and peril. Understanding these phenomena is crucial for our preparedness. It was a once-in-a-generation event that left spectators in awe. But beneath this celestial spectacle lay a potent cosmic danger. It swings between periods of low and high activity known as solar minimum and solar maximum. Are you intrigued by the connection between the Sun and Earth? Would you like to dive deeper into space weather and other captivating science topics? If so, consider giving this video a thumbs up and sharing it with those who might find it interesting. Your engagement helps us continue delivering thought-provoking content that explores the intricate workings of our universe. Moreover, if you're eager to stay updated with our latest content, remember to hit that subscribe button. Doing so ensures you won't miss any of our captivating videos that unravel the mysteries of the cosmos and the advancements in science and technology. Together, let's continue to explore and understand the wonders of our universe. Currently, we're in solar cycle 25, and it's showing signs of becoming one of the most active cycles in decades. This means the frequency and intensity of solar flares and CMEs are likely to increase. Events like the May 2024 storm could become more frequent and potentially more severe. As we head closer to the solar maximum expected in 2025. So what happened in May 2024? Why did the auroras dance so wildly? What does it mean for Earth? What is a solar storm? Picture the sun as a massive ball of churning plasma and magnetic fields. It's a dynamic environment teeming with activity. Solar flares are sudden bright bursts of energy from the sun's surface. CMEs are giant expulsions of plasma and magnetic field from the sun's outermost atmosphere, the corona, Earth's shielded magnetosphere. But Earth isn't defenseless. It's protected by a protective force field known as the magnetosphere. Generated by our planet's molten core, this shield deflects most of the sun's harmful radiation and charged particles. However, when a CME collides with the magnetosphere, it can cause what's known as a geomagnetic storm. Geomagnetic storms occur when a CME's magnetic field connects with Earth's magnetic field lines and allows solar particles to pour into the planet's atmosphere, the Aurora's allure. As these energized particles funnel down to Earth's upper atmosphere, they collide with atoms and molecules of gases like oxygen and nitrogen. These collisions excite the atmospheric gases, causing them to release light. Different gases at different altitudes produce different colors, creating a mesmerizing light show. Oxygen atoms at lower altitudes create the most common color green, while higher altitudes produce red. Nitrogen molecules emit blue and violet hues. The result is a breathtaking panorama of shimmering lights dancing across the polar skies. The hidden threat. Solar storms impact while these auroras are undeniably beautiful. They're also a reminder of the hidden threats posed by solar activity. Satellites and communications. When a solar storm hits, it can swell Earth's upper atmosphere, increasing drag on satellites. Power grids. This is perhaps the most concerning threat. Radio communications and aviation solar storms can also interfere with high-frequency radio communications. Astronauts in space travel outside Earth's protective atmosphere and magnetosphere. Astronauts face elevated radiation exposure during solar particle events. A look back. Historical precedents. The Carrington Event of 1859 holds the record as the most violent solar storm in history. In 2012, Earth had a close call with a CME that could have been as powerful as the Carrington Event. Our sun's activity cycle. It's crucial to remember that the sun operates on an approximately 11-year cycle of activity. The big question, are we prepared? The question isn't if a Carrington-level event will happen again, but when, and are we ready? Early warning systems organizations like NOAA's Space Weather Prediction Center continuously monitor solar activity. Grid hardening efforts are underway to make power grids more resilient to GICs. Satellite design. New generations of satellites are being built with more radiation-hardened components and fault-tolerant systems to withstand solar outbursts. Staying vigilant, looking ahead. As we continue to rely more on technology, our vulnerability to space weather increases. Solar storms are a reminder of our place in the cosmos. As solar cycle 25 intensifies, staying informed about space weather becomes increasingly important.